going to try to work on some homework problems from page 48 and 49. The first few problems you were asked to determine the domain. So if we talk about domain of an expression, the domain is going to be all real numbers, so that's from negative infinity to positive infinity, unless you have a variable in the denominator. Unless you have a variable in the denominator, or you can't have a negative under a square root. All right, so either of those things would restrict our domain. In other words, the domain is what can x be, and it couldn't be certain things if we have one of these situations, or if in the problem they limit the domain, they limit what x can be. Okay, so on problem number 2, that's what we're going to start with. We have 2x squared plus 5x minus 2. There is no denominator. There's no square root, so my domain on this is all real numbers, which would be negative infinity to positive infinity, and that would be my answer. Problem number 4. Problem number 4 is 6x squared minus 9, which would be all real numbers, except for then they say, comma, x must be greater than 0. So normally 6x squared minus 9, if I were to graph it, would be all real numbers, but they're telling me the x values has to be greater than 0. So in this case, my domain would be from 0 to infinity. And I put a parentheses at 0 because it says x has to be greater than 0. If it had said greater than or equal to, I would have put a bracket. All right, number 6. X plus 1 over 2x plus 1. Okay, this has a denominator. This denominator cannot be equal to 0. So what I'm going to do is figure out what value of x would make it equal to 0, and then say x can't be that. So subtract 1 from both sides. I get 2x equals negative 1, divide by 2. So negative 1/2, x can't be negative 1/2. So on a number line, what that's looking like, it's going to be all this stuff, and then I've got negative 1/2 right here. It can't be that, but then it can be all this stuff. So how we write that is we say it's from negative infinity to negative 1/2 with a parentheses, meaning it's up to it but not including it, and then union negative 1/2 to infinity. All right, and then problem number 8. The square root of 6 minus x. What's underneath here can't be negative. Can't be negative. And so what we write is we write 6 minus x must be greater than or equal to 0. That's how we say can't be negative mathematically in an equation. So I'm going to solve this. I'd subtract 6 from both sides, and that give me, cancel out, negative x is greater than or equal to negative 6. Divide both sides by negative 1. When you divide an inequality by negative, it reverses this symbol. So it becomes x is less than or equal to 6. So on a number line, what that would look like is at 6, it could be 6 and everything less than that. So I would write from negative infinity, because you know this side's negative infinity, this side's positive infinity. These x values go from negative infinity up to 6, and I put a bracket because it can equal 6. All right, and then we moved over to problem number 12, where you had to start simplifying. And in 12, it's 18y squared over 60y to the 5th. So what I want to look for is I want to look for common factors. Like 18 and 60 can both be divided by 6. 18 divided by 6 is 3. 60 divided by 6 is 10. And y squared and y to the 5th have a common factor of y squared. I could remove all of them here, and that would leave me with y cubed on the bottom. So my answer to number 12 would be 3 over 10y cubed. Number 14. I've got 2x squared y on the top and xy minus y on the bottom. You can't cancel anything on the bottom unless it's a factor. I can't cancel with the x's and the y's because that's a term, and you can't, when there's a plus or minus, that has to stay together. So 2x squared y is going to stay on the top. I'm going to factor the bottom. It has a GCF, with xy minus y. My GCF is y, and that would be y times, if I were to take a y out, factor it out with a GCF, that'd be leave me with x minus 1. See, x times y, and then y times 1 would give me the y. So that's how this factors out of GCF. So then, looking at common factors, I could cancel a y out, and my final answer would be 2x squared over x minus 1. All right, number 16. 9x squared plus 9x over 2x plus 2. The top has a GCF of 9x, and that'd be times x plus 1. And on the bottom, a 2, and that'd be times x plus 1. So this cancels out, and I get 9x over 2. And that would be my answer. All right, number 18. I have 12 minus 4x on the top and x minus 3 on the bottom. The top has a GCF of 4. It's 4 times 3 minus x, and the bottom is x minus 3. 3 minus x and x minus 3 are exactly opposites of each other. Notice the 3 is positive and the x is negative up here. And the x is positive and the 3 is negative, so I can cancel them out if I replace it with a negative 1. So 4 times negative 1 is negative 4, and that's my answer on number 18. And number 20. I've got x squared minus 25 on the top and 5 minus x on the bottom. So the top factors to x plus 5 and x minus 5, and the bottom is going to be 5 minus x. X minus 5 and 5 minus x are opposite each other. I can cancel them out if I replace it with a negative 1. So the top is going to be a negative 1 times x plus 5. I don't have to write a negative 1. I can just write a negative. Negative times x plus 5. I'm going to do a couple more. 22. I've got x squared plus 8x minus 20 on the top, and x squared plus 11x plus 10 on the bottom. All right, on the top, I need two numbers that multiply to give me, I'm going to put an x and an x. I need two numbers that multiply to give me a negative 20 and add up to a positive 8. So that'd be positive 10 and negative 2. And on the bottom, I need two numbers that multiply to give me 10 and add up to 11. So that would be 10 and 1. So the 10, x plus 10's cancel. My answer for 22 is x minus 2 over x plus 1. Number 24. X squared minus 7x plus 6 on the top, and x squared plus 11x plus 10 on the bottom. We just factored this same bottom. It was x plus 10, x plus 1. No need for me to think about doing that again because I just did it. On the top, I need two numbers that multiply to give me a positive 6 and add to a negative 7. So that'd be negative 6 and negative 1. Those multiply to give me a positive 6, and they add together to give me negative 7. Nothing cancels here. So this is factored. It's factored as it gets. Nothing can cancel. 26. The top is x squared minus 9. The bottom is x cubed plus, ooh, that's a 3, plus x squared minus 9x minus 9. All right, the top is a difference of squares. That'd be x plus 3, x minus 3. The bottom I'm going to factor by grouping. The first two have a GCF of x squared, and that'll leave me with x plus 1. And then I have a negative 9, and that'd leave me with x plus 1. So I get x plus 3, x minus 3. And on the bottom, this common factor is x plus 1. And the other factor would be x squared minus 9, which can be factored to, so I've got x plus 1. X squared minus 9 can be factored to x plus 3 and x minus 3. And so that cancels and that cancels, and I get 1 because there's nothing left on the top, so I put a 1 on the top and x plus 1 on the bottom. All right, 28. And then I'm going to pause and start a new video because it just kind of changes what we're doing. The top first has a GCF of y. So if I take out a y, I would have y squared minus 2y minus 3, which is y times, it's y minus 3, y plus 1. Two numbers that multiply give me negative 3 and add together give me negative 2. And then this is a cube, so it'd be y plus 1. And it'd be y squared minus y plus 1. Remember your SOAP method? It's the same, and then it's opposite opposite sign, and then it's always positive. And you square the first and square the last and multiply them together for the middle. Okay, the y plus 1's cancel. So your answer is y times y minus 3 on the top and y squared minus y plus 1 on the bottom. That doesn't factor. All right, I'm going to pause it here and pick up with multiplication, division, addition, and subtraction in the next video.